Now, I released multiple videos where I dive into different AWS services, and in many of these videos, we started some basic web server exposing a website to the world. But in all those videos, we just used the default DNS name, the default automatically generated domain name that was provided by AWS, because of course that was enough for these demos. Typically though, if you do, for example, run a web server on an EC2 instance or with help of other AWS services, then you want to have your own custom domain attached to it. And not just that, you also want to optimize performance and delivery. You want to make sure that people visiting your website from different places on the world can all see your website as quickly as possible. And of course, since typically you're using one specific region, like North Virginia or any other region from here, but since you're typically using one region in which you run your web server, again, for example, on an EC2 instance, that means that for people that are close to that region, they will have an easier time seeing your website than people that live far away from that region, because a request sent to your web server has to travel through a global network of cables all across the globe to this AWS data center in this region, which hosts your website. That's why you often might want to use another AWS service called CloudFront, which actually distributes cached copies or cached items from your website across many data centers, you could say, all over the world, so-called edge locations, which are also owned and operated by AWS. These edge locations are not data centers you can actively select or rent, but you can use them through another service called CloudFront, which actually does distribute your content through those edge locations to make sure that users can actually get access to your content, your website, in a quicker way, because their requests just have to reach the closest edge location instead of traveling all over the world. Now in this video, we're going to see how we can use our own domains and how we can use CloudFront. And by the way, you don't always have to use these two features in conjunction, even though often you will. Now, as always, this video here is not there to get you started with AWS or all the different services offered by AWS. Instead, this video is there to give you some hands-on experience and practice and show you a real example. If you want to get started with AWS and learn about all the core services it has to offer, you might want to check out my Cloud Practitioner course, which does get you started with AWS and even helps you pass your first certification, the Cloud Practitioner certification, in case you're interested. Now, for that video, I do provide another demo code base, which you also find attached to this video. And it's a very simple web app that is started by this app.js file in this code, which I'm providing. It's using Node and then the Express package to basically listen for requests on one single path. And then I send back a predefined HTML page, which also isn't too fancy, but which does come with some styles and an image. And in this code, I also define some caching settings. To be precise, I want to make sure that data can be cached, and I'm setting the appropriate headers on all outgoing responses to let browsers and other parties like CloudFront know that this data, for example, the image or the style file or the HTML content here, can be cached for a certain period, 2 minutes here in this case and 10 minutes here, until it has to be fetched again. And this will be important for the CloudFront service because that service will take a look at these headers and then cache the data on these edge locations for these periods. And after this time span here, it will fetch new data from the so-called origin. So CloudFront will reach out to your web server and get the latest data whenever this period is exceeded, and then it will cache that newly fetched data for that period again. That's essentially how CloudFront will work. Though it will not automatically reach out to your origin and fetch that data, instead it does so when users start requesting that data. But then not all requests have to go to your actual server, but instead most requests can be handled by those edge locations because data is cached based on the cache settings you define in your web application. And that's why this basic application is basic, but pretty good for this example. Therefore, what we need here is this web server up and running, again on an EC2 instance in this case. Hence, I will go here, launch a new instance, and then there stick to the basic default AMI and the default instance type, select no key pair, and a security group that actually does provide HTTP access, as this one does. Configure no storage, and under advanced details, we just need to add some user data. Some user data, which is of course also attached, which does spin up that web server and download the code before it does that, and so on. It's the same user data basically as used in all these other videos. So with that, I'll launch this instance, and then we'll wait until this instance is up and running. Now, after a while, this should all be up and running, and we can use this automatically assigned domain name to visit this website. So that's now this basic website being served by this web server running on this EC2 instance in the US East 1 region in my case. Now, because of these caching headers, my browser actually also caches the data once I visited it, and therefore all that data is downloaded and shown extremely fast. But only when I visit this the second time. The first time it takes considerably longer because there a request has to be sent to that web server, it must be handled there, and the response must travel back to my machine. And since I'm in Germany and my server is in the US East 1 region, this takes some time. Now, this local caching in the browser is of course great, but it does not help users that visit our website for the first time. And that's why we want to use CloudFront, so that not every user has a bad experience on their first visit, but that instead the vast majority of users can benefit from data cached on these edge locations, so that the first visit for those users goes to the edge location instead of our actual server in the US East 1 region. But before we even use CloudFront, I want to quickly talk about this automatically assigned domain name. As mentioned, that's the domain name we saw and used through all these other videos as well, but very often you might want to use your own custom domain name. And AWS has another service totally unrelated to caching and CloudFront or anything like that called Route 53. Route 53 can be used to register and manage your own domains. Now here I don't have any domains, but you can also purchase domains through Route 53. And whilst this does cost you money, I will do it here to show you how this would work. Now here I'll quickly register some dummy domain name like demo1 dummy. Let's see if that's available. It is. And then I'll add this to my cart and continue. And after filling in all my details and confirming some terms and conditions, I complete this order. Now it can take a while until this registration is active, and of course you should not try it on your own with your own domain if you're not willing to pay money, but I'll be back once this was registered so that I can then show you how you could then make sure that this domain points at this EC2 instance we just launched a couple of minutes ago. Now, once a domain was registered, AWS and Route 53 automatically creates a so-called hosted zone for that domain. And a hosted zone is simply a container for the different records, the different settings related to the domain. If you click into the hosted zone that was created for this domain, you see that it has two records out of the box, and the most important record is the first one where the name servers for that domain are defined, and this in the end is an internal but very important record and setting that makes sure that the domain can be discovered and used by browsers. You should not delete these two default records unless you really know what you're doing. But you can add new records, and with records you can simply control how this domain can be used. You can, for example, make sure that if a request is sent to demo1-dummy.com, this request is forwarded to the EC2 instance. That can be controlled with help of a record. You could also connect it to a mail server so that you could have your own email addresses, something at demo1-dummy.com with a different kind of record. But this is not a video where I want to dive deeply into domains and what you can do with them, but instead I want to show you how you can connect a custom domain to a website served through some other AWS service. And in this case, we got this instance, this EC2 instance that runs our web server. This web server, which we reach through this address here. Now, if we would want to use our own custom domain, then we could copy this public IPv4 address that was assigned to this EC2 instance automatically by AWS and create a so-called A record, which is a record type that's used for sending traffic to IPv4 addresses. And then we could paste that IPv4 address into this value field. You could also set this up for a subdomain like test.demo1-dummy.com or for the root domain, for the main domain, so to say. Now then you can also set a time to live, which simply means for how long this is deemed to be the correct value, and if browsers then send requests to that domain and you change these domain settings, it can take up to this amount of seconds until any changes propagate and are picked up. So here I'll actually set this to just 1 minute to make sure that if I would change the IP address here, browsers would pick up that change after 1 minute, and then we can create this record. And now this record here is added, and therefore we should now be able to visit our domain in the browser and still see our website. It can take a while initially, but thereafter our browser should successfully load that website for our own domain. Now that's one thing we can do, but this approach has a serious flaw. This IP address here was assigned automatically by AWS, and whenever we terminate and restart this instance, we'll get a new IP address. So this IP address is not fixed, it's not stable, instead it can change. Now, of course, we could update our A record whenever we restart the instance, but a better solution would be to use an elastic IP. Now that's another feature I discuss in my course. In the end, elastic IP addresses are IPv4 addresses you can request, which are then reserved for you. And because IPv4 addresses are a rare resource, we're running out of these addresses, you can't request an infinite amount, and you will also pay for elastic IP addresses you're not using, so that you're incentivized to use them. But you can allocate a new address here from inside the elastic IP address area in the EC2 service page. You can assign it to a specific region, and then with that address allocated to your account, you can attach it or associate it, as it's called, to an EC2 instance. So here I can associate this elastic IP address with my instance. Now this IP address will not change when I terminate the instance. Whenever I start a new instance, I can reassociate this IP address with that new instance, and therefore this IP address will always be stable and will not change. So now if I associate this to my instance, I can use this allocated public IP address here, this elastic IP, and use this as a value for this A record instead of that IP address that was assigned automatically by AWS. And that's now a better way of handling this. Now it can take these 60 seconds until these changes are picked up, but thereafter, when we visit our website here, we will visit it with help of that elastic IP that points at our instance. Here we go. So that's how we could point at a single instance. More often than not, you will also use a load balancer though, because you might also have auto-scaling turned on or you're running your web server on multiple instances manually. Therefore here, to simulate this, I will add a load balancer, and as a first step, I'll add a target group, therefore. Now, I also do introduce you to load balancing and auto-scaling in my course and also in another video I created. Therefore, here I'll just briefly walk through the steps that are required to create a load balancer for my instances here. Here, I'm also not going to set up auto-scaling, and I'm creating the load balancer even though I only have one instance. Of course, that might not make too much sense, but as mentioned, this is just a demo. For a real web server, you would typically have multiple instances, possibly because you're also using auto-scaling. Now, when creating a new target group from scratch, we have to choose what our targets are, and here in this case, we'll have instances as targets. I'll give this target group a name of TG1. Then the requests will be sent to port 80 because that's the port on which I'm listening on those instances. I select my VPC that holds those instances. We can set up the health check settings so we can configure to which port and path HTTP request will be sent to find out whether an instance is up and running and working as intended. And then with that, we created this target group, and we can now select this one instance which we have up and running and include it into this target group so that it is part of that group. And now with that group created, we can create a load balancer for that group. Therefore, we create a new load balancer, here an application load balancer, which is typically your default choice for HTTP requests. I'll name it Demo 1. It's an internet-facing load balancer because I do want to accept requests from the internet. It's for the same VPC as before. I select all the subnets in that VPC so that this load balancer is able to distribute traffic across targets in all availability zones. I want to make sure that I add a security group that does actually allow HTTP traffic. And then I forward traffic that arrives on port 80 to this target group which I created before, like that. With that done, we can create a load balancer, and whenever we create such a load balancer, we also get another domain name assigned to it automatically by AWS. And this domain name can then also be used to send requests to that website that's served by the instances that are covered by this load balancer. So once this load balancer did finish its setup phase, once it is available, we could use this domain here to send requests to our website. Here we go. That's the website loaded with help of that domain name automatically assigned to the load balancer. Now, of course, again, that's this automatically created domain. We might not want to use that. In order to use our custom domain, we can tweak this A record. But now we don't have an IP address we can put in here because the load balancer, the application load balancer at least, does not have an IP address which we can view or use. The network load balancer would have an IP address, but the ALB does not have that. Now we could come up with some construct where we have a network load balancer in front of an application load balancer or anything like that, but we don't need to do that. Instead, what we can do here, and that's a special feature of Route 53, we cannot enter a value here, but instead turn on this alias setting here. And this allows us to directly point at specific AWS resources as targets for this record, this A record here. So once we switch to alias, we can no longer enter a value. Instead, now we choose a target for the traffic that targets this domain. And here you see that we could, for example, select an application load balancer, amongst many other things, many other services we can use as targets. So here I choose the application load balancer, and here I know I'm in the US East 1 region, and then it's this load balancer, which is automatically suggested here. So once we save this, our custom domain will now point at this load balancer, and that's therefore how we can attach a custom domain through Route 53 to our own load balancer. If I now enter this domain, I again see the website, but now with help of that load balancer. So that's how we can use Route 53 with EC2 instances or our load balancer. But as mentioned earlier in the video, this video is not just about connecting custom domains, it's also about optimizing content delivery with help of caching at the edge with help of the CloudFront service. And therefore that's the service we'll visit next. CloudFront gives us access to these edge locations and makes sure that certain responses by our web server are cached on these edge locations so that users can send requests to these edge locations which are closer to them than our main server, which is in one single region, so that ultimately our website is delivered faster to our users. Now, we simply start by creating a so-called CloudFront distribution. And as a first step, we have to choose an origin. That's basically the main server or the main thing that contains our content that should be cached at the edge. That could be a S3 bucket. It can also be an Elastic Load Balancer though, like here the load balancer which we have. Also note that this is a global service where you don't have to pick a region, because the idea behind CloudFront is that it uses this global network of edge locations. That's why you don't have to pick a region here. Now next you have to choose which protocol should be supported, and here we know that we listen on port 80, so I pick HTTP only here, and requests are therefore sent to port 80. We could also add a specific path to which the requests should be forwarded on the origin server, so that requests to this CloudFront distribution are forwarded to a different path, to a different file, for example. We can give this a name and we can keep all the defaults. And we could add custom headers that are attached to the requests that are forwarded from CloudFront, so from these edge locations which are hit by the user's requests, to the origin server. So if you wanted to add extra headers, you could do that here as well, because you must not forget that now you have two requests technically, one request from a user to their closest CloudFront edge location, and then one request from that edge location to your origin server, your main server, the load balancer in this case. You can turn on Origin Shield, which is some DDoS protection you can turn on, some distributed denial of service attack protection, and further settings which you could switch on, but all the defaults here are fine for us, and the more interesting parts are the caching behaviors, which we can define down here. Here, you can choose whether responses should be compressed, so made smaller automatically. You could, for example, make sure that HTTP requests are forwarded to HTTPS, and this only affects the requests from your users to CloudFront. So this is not relevant for the request from CloudFront to the origin. There it will still use HTTP because of our setting up here. So here we can configure that our users can actually use HTTPS when we use CloudFront, even though our origin does not support it, because here we're controlling the request from the visitors to the CloudFront edge locations. And hence I will actually choose redirect HTTP to HTTPS to enforce HTTPS for these requests. We can then control which kind of request types should be supported. And unsupported types will always be forwarded to the origin server. Supported types can be cached, so responses for these supported request types can be cached on the edge locations. And we can then choose from various caching policies which control in detail how data is cached at the edge locations. With the defaults chosen here, the cache settings set in your code, like a max age for the response, will be taken into account, but you can also create your own policies or view these policy settings to understand how data may be cached and how certain rules can be overwritten. For example, you could ensure that for caching, the query string that's part of the request path will be taken into account or not. With all that done, there are some more advanced settings which you can set in addition, like for example, you could turn on logging, and then you can associate functions. Now, functions are simply code snippets that you can execute whenever a request hits an edge location or is forwarded to the origin, or once a response is coming back to the edge location or to the user. These functions could be used to transform the request, to inject extra headers or data, or do anything like this, but here we don't need that feature. Now next, you can also choose whether all edge locations all over the world should be used or only in certain regions. And of course, if you know that you, for example, only have customers from the US and Europe, you could save some money by only using some edge locations, but here I'll use all. You could also add the extra WAF service, the Web App Firewall service offered by AWS, which allows you to inspect incoming requests and block certain requests, for example, based on data that's inside of them. And you can also add your own domain name here, basically, but will not do this at the moment here. You can also use your own SSL certificate, but here I'll use one which is created automatically by CloudFront, since I also won't use a custom domain. So with all these settings chosen, you can create this distribution. And now this will take a couple of minutes to set up. But thereafter, we will be able to send requests to this CloudFront distribution, and under the hood, a request will then be sent to an edge location, the closest edge location for us actually, and then from there it will be forwarded to the origin server if no cached response was found on this edge location. Otherwise, that cached response will be returned to us, and therefore for most visitors, our content will be returned faster than it would otherwise. So let's wait for this setup to finish and for this to be deployed, and thereafter let's see it in action. Now, once deployment finished and this is up and running, we can again use a domain name that was assigned automatically by AWS, send a request to it, and now we see the same website, this time loaded with help of CloudFront, so with help of this at the edge caching. As always, we might not want to use this domain name here though, and therefore we can go back to Route 53 and there to our hosted zone and edit this A record, which currently points at the load balancer, and now use this CloudFront distribution instead, because this has the extra advantage of this cached content which is delivered faster to our users than if users directly talk to the load balancer. Therefore, we switch the alias to the CloudFront distribution and select this CloudFront distribution thereafter, but we don't find it there. If I switch to another setting and back to CloudFront, it's still not suggested to me. The reason for that is that if we want to use our own domain here, we have to edit the settings of this distribution. And we have to add a so-called CNAME here under alternate domain name. Here we have to enter our domain name, which we plan to connect to this distribution. So in my case, demo1-dummy.com. And only if that is added here, we'll be able to use this CloudFront distribution as a target in Route 53. Now with that added, we can save these changes. But now we also get a warning that we need to add a certificate, a SSL certificate, if we want to use our own domain name. The reason for that is that CloudFront distributes its content to the end users via HTTPS, so via a secured connection where we encrypt all the data that's part of those requests. And therefore, our domain name here must support this SSL encryption. Thankfully, that's easy to enable by requesting a certificate from another AWS service that issues such SSL certificates, the AWS Certificate Manager. We can request a certificate right from inside this CloudFront service page, and we're then forwarded to the ACM. And here we also paste in our domain name for which this certificate should be. We keep all the other default settings and request this. So now we have this certificate requested. In order to activate it, we now must prove that we own this domain. And for that, we can click into it and then create these validation Route 53 records automatically with this button, or add a CNAME record manually. But here I'll click Create Records. Create Records. And this now creates the records which are needed to prove that we own this domain and that therefore this certificate can be activated. In the Route 53 console, you will now see that a new record was added, and that is this validation record, which is needed by the AWS Certificate Manager. With that, this will soon be validated and active, and therefore, back in the CloudFront console, we can select this certificate once it has been validated. So I'll briefly wait for that to happen. Here we go, it is now active. Therefore, now if I refresh here, I can select it. And now with that selected, I can save these changes, and now the CloudFront distribution was updated, and we can now forward requests from our own domain to this CloudFront distribution. For that, we can go back to Route 53, to this A record, edit it again, switch to the CloudFront distribution, and then select this distribution, which is now suggested here because we added our own domain name as an alternate domain to it. So with that all done, this is updated. And now if we send another request to our custom domain, it will actually be sent to CloudFront and therefore to the closest edge location. And now we're serving this website in a highly optimized way where copies of important parts of the website, important pages of the website are cached at these edge locations so that the content is delivered to our users as quickly as possible. And under the hood, we're using CloudFront, an application load balancer, and the EC2 instance that runs the web server, or possibly multiple instances with autoscaling maybe. And we're using Route 53 to connect our own custom domain. And in this video, you now saw different approaches. This ultimately might be the best solution because we have this optimized caching and we have this quick delivery of content. But sometimes you also just need the load balancer. You might not care about the edge location caching, and therefore you also saw how you can forward requests to custom domains directly to the application load balancer or even directly to the EC2 instance, either with elastic IPs or the automatically assigned IPs. Now, since we're now done with all these services and things, I will remove all the resources that we created in this video, starting with the load balancer, which I will delete here, and also the target group, which we created, which is not needed anymore. I will also shut down that instance that I started, this EC2 instance, and terminate that. And on the CloudFront service page, I'll disable this distribution, and once it is disabled, which also takes a couple of minutes, I'll also delete this distribution. In the meantime, for Route 53, I can remove this A record here. And of course, we could also get rid of the entire domain, though we won't get our money back. We just can make sure that we don't renew it next year. That's the only thing we can do, but we can't give it back and get our money back. That won't work. I will also go to the certificate manager and get rid of that SSL certificate, which we did create, at least once the CloudFront distribution was deleted, because we also don't need that anymore. Here we go, the distribution is fully disabled. Now I can delete it. And thereafter, I can also get rid of this certificate here. So that's what I'll also do.